All right, in this video lecture, we are going to be talking about producing products again and production processes. But in this case, we are learning exclusively about machining. So, as you all know, I am a tool and die machinist by trade. So, this is a process that's near and dear to my heart. So, some of the key terms that you want to get to know are drilling, turning, lathe, sawing, milling, shaping, broaching, abrasive machining processes. Make sure that you understand and know what those are by the end of this video or doing your coursework this week. Our objectives here are to identify all of the different types of machining processes that we use to make parts and products. We're going to describe the conventional machining processes, and we're going to do a little bit this week about describing advancing machine processes as well. All right, so what is the role of machining? Well, basically, machining cuts and shapes a variety of different products and materials, whether we're talking about wood, all sorts of the different metals, aluminum, brass, bronze, alloys, high-speed steel, tool steel. We use machining to shape these different materials. It's generally done after molding and casting. It adds more detail and precision. And basically, sometimes you can get imperfections in cast and molds. In our class, if you've probably noticed on some of the composite decking material that we use, sometimes there's air pockets and cavities in there. Those are imperfections that kind of occur in both castings and molds when they're formed. So we also use machining to make holes or improve surface finishes on those holes. And of course, we would remove any excess material there as well. So our conventional machining processes are drilling, turning, sawing, milling, shaping, broaching, and abrasive machining processes. These could be manual machines where a operator or machinist is cranking the dials and cutting the part, or they might be CNC machines, computer numeric control machines, where you have an operator that sets it up and then basically you run production on that. All right, so one of the most common machining processes out there are drilling. We make a lot of holes, and there's a lot of different processes that actually kind of go into the hole making aspect of these parts. I mean, because holes can be chamfered, countersunk, or tapped. We might bore those holes out to help straighten and make them round. We might ream them for extreme accuracy and to smooth the surfaces there. So we have a lot that goes on with our holes that we need to put into parts. We also have a process called trepanning, which basically removes like a big disc or a slug of material out there with what's called a trepanning tool. Turning basically makes round parts. So, and we use a lathe to do this. So imagine if you go down to Louisville, Kentucky, and go into the Louisville Sluggers Museum, they turn a lot of bats on lathes. So out of wood, of course, a metalworking lathe is similar, where we're going to basically turn parts. And they might be straight turned. They could have a taper. We might even be able to put some type of a contour on there. So if you imagine like a chess piece, like a pawn or a queen, we might be able to just kind of turn that contour of the chess piece to make those pieces. All of these are turned on a lathe, and the main thing here that I want you to take away from this is that your part is actually rotating and your cutting tool is moved and pushed through the rotating part in order to cut and make the shape. Sawing uses thin blades. Those blades have equally spaced teeth, and we cut through the material. Of course, our common types are bandsaw, reciprocating saw, and circular saws. You are probably more familiar with the circular saw, probably have one at home. Probably also have a reciprocating saw in the form of like a saw, a jigsaw of some sort there too. And of course, in industrial processes, we use bandsaws and hacksaws as well. So these are generally the very first process that's being done when we have bar stock and we need to cut that bar stock into smaller lengths. That way we can go ahead and process that and get it put into our machine tool. Milling is probably where I've done the most work in my career. It's one of the most versatile machining methods that we use today. We can make round parts, we can make square parts, we can drill holes. So there's a lot of things that we can do with the milling machine. It allows us to cut a large variety of different shapes. So as a matter of fact, for the most part, with a milling machine, there's not too many shapes that we can't make on it with the right application and the right cutting tools. So we can also cut all of those holes as well very accurately too. So um, our work holding methods and cutting tools are important in this. And of course, the extent of knowledge that you would need to know about all of those work holding methods and cutting tools on a milling machine would be pretty extensive there too. There's a lot that you need to get to know in that regard. Shaping and broaching are kind of the two similar things. Shaping and shapers have kind of fallen out, but basically we're more or less shaving material away with either shaping or broaching. You still have a lot of shapers used in woodworking, so they produce flat or possibly curved surfaces as we cut those and cut into that material. Broaching is used often for keyways or slots. We can change the shape of a hole. So if you've got like a round hole, we can kind of put a hex broach through that and get us a hex shaped hole in there. We could even put a square broach into that and make a square hole out of it as well. So a lot that you can do with a broach depending on what you need. We also talk here about abrasive machining processes. Now, abrasive machining processes are going to use sand or stone that shapes, smooths, and polishes the surface. Of course, you're all familiar with sandpaper, so that's an example of a abrasive product, and it's got different types of grits that we might use depending on how rough or smooth we want the surface to actually be, or how polished we want the surface to be. So it's abrasive machining and abrasive materials are used pretty extensively across all of the trades. So in the machining side, we talk a lot about grinding and sanding. So if we're grinding, we're going to use some type of a grinding wheel that has abrasive material bonded together on that. And we usually would put that on like a pedestal grinder or a surface grinder or cylindrical grinder where we have that abrasive wheel. We talk about sanding using all of the different papers or cloth that's generally made into sheets, belts, or discs that we use. And of course, that grinding and sanding gives us a nice finish process, and we can use that to hold tight tolerances and improve those surface finishes as well. Now we talk about the advanced machining processes. We're not going to talk too much about these. You guys are going to do assignment on your own where you learn about these. But these advanced machining processes are called chemical machining, electrical discharge machining, otherwise known as EDM, electrical chemical machining, known as ECM, ultrasonic machining, laser beam machining, electron beam machining, plasma machining, and of course, one of the newer, more interesting technologies is the water jet machine as well. So you guys will be given one of those to kind of do a little research on and give us a little bit more information on what those processes are. All right, so that's pretty much going to end this lecture. When we come back, the next lecture, we're going to be going over what's known as conditioning, finishing, and assembly as well. So stay tuned. That lecture will be coming up. But for right now, just concentrate on knowing all of your different machining processes and do a little bit of research here so that you know what the advanced machining processes are all about.